Welcome to 5.6 half-angle identities. Now we will work on example 3. Given cosine of A equals -3/7, where A is between pi and 3 pi over 2, find the values of sine of A over 2, cosine of A over 2, and tangent of A over 2. Let's start with sine of A over 2. First, let's write out the identity, where sine of A over 2 is plus or minus big old square root of 1 minus cosine A all over 2. Now notice they gave us cosine A, so we just need to simply plug that in. So I will replace the entire expression cosine A with -3/7. One option here is to clear the denominator by multiplying top and bottom by 7, because 7 is the innermost denominator. However, I found that most people go ahead and just add those two fractions together and then divide by 2. Off to the side, I'll go ahead and calculate 1 plus 3/7 all over 2. So I will rewrite the 1 as 7/7. So I get 10/7 up top and 2 on the bottom, which is the same as 10/7 times the reciprocal, which is 1/2. So I get 10/14, which reduces to 5/7. I can split up the radical into rad 5, rad 7 to rationalize, but now let's decide if this is positive or negative. So we are told that A is in between pi and 3 pi over 2. But we're interested in half A. So I'm going to multiply everything by a half. Once we multiply everything by a half, we get pi over 2 and 3 pi over 4. So A over 2 is in between pi over 2 and 3 pi over 4. So let's figure out where that is. Well, we know pi over 2 is here. 3 pi over 4 is in the second quadrant. So if a over 2 is in between there, we know that a over 2 must be contained in that second quadrant. So sine will be positive. Now we can rationalize the denominator. Sine of a over 2 is rad 35 over 7. At this time, to find cosine of a over 2 or tangent of a over 2, we could, of course, still use the half-angle identities for cosine of a over 2 or tangent of a over 2. Since we already know the sine of a over 2 is rad 35 over 7, now we can draw a picture of a over 2 where y is rad 35 and r is 7 and find out what x is, and that will allow us to find cosine of a over 2 and tangent of a over 2. Similarly, we could use the Pythagorean identities. So we already found that a over 2 will be in quadrant 2, and I will use the sine of a over 2 as rad 5 over rad 7 before rationalizing so that our numbers are smaller. So now we can use Pythagorean theorem to find x. Squaring the rad 5 gives us 5, and squaring the rad 7 gives us 7. X squared plus 5 equals 7. Subtracting 5 from both sides gives us x squared equals 2, or x is plus or minus rad 2. Since we are in the second quadrant, x will be negative rad 2. Now remember, this picture here is our picture for the angle a over 2. So we can go ahead and find cosine of a over 2 is x over r, or negative rad 2 over rad 7, and tangent of a over 2 is y over x, or rad 5 over negative rad 2. Cosine of a over 2 is negative rad 14 over 7, and tangent of a over 2 is negative rad 10 over 2. We will be skipping example 4 since we already covered that exact same type of example in 5.5, and I believe that the method from 5.5 is the better method. Example 5, simplify. A plus or minus square root of the quantity 1 minus cosine of 8x all divided by 2. So the first thing you want to do is see if this looks familiar. We know our square roots come about in our half-angle identities. Notice the 1 minus cosine all over 2 is our half-angle identity for sine. So notice this quantity will be the same as sine of a over 2. So now we have to compare what is a. Well, everything is the same except the 8x and the a. So we have that the a must be 8x. So therefore this will be equal to sine of 8x over 2. We can divide the 8x and the 2 because they are both within the sine function. So our final answer is sine of 4x. One thing to notice that when you are finding the half angles, this right here, this number out here is always going to be half of this angle right here. So same thing, this angle right here is half of that angle inside. B, plus or minus the square root. 1 minus cosine 9b over 1 plus cosine 9b. So again, comparing it to our half-angle identities, we notice the 1 minus cosine over 1 plus cosine inside a square root is the half-angle identity for tangent. And this is equivalent to the tangent of a over 2. So comparing these, again, we can see that our a is 9b. This quantity is the same as tangent of 9b over 2. And since 9b over 2 cannot be simplified any further, that is actually our final answer. Both of these are situations where it's really trying to identify the patterns. So first you identify the pattern and then figure out what has to go in to your trig function. So here it was 8x over 2 or 4x or 9b over 2. I hope you enjoyed the video. See you next time.